Okay, today we're going to learn to integrate x to the negative 1, and then we'll also do some trigonometric functions. So I want you to consider first to find the derivative of this particular function. Well, if I'm going to find the derivative, it's dy over dx is equal to 3 times the derivative of ln x is 1 over x, so I get 3 over x. Well, if this is the derivative of 3 ln x, I want to now go backwards and find the integral, or the antiderivative of 3 over x. Well, I know it's going to be 3 ln x. And there's a couple ways I can do it. I can just think backwards, or I could also pull out the 3 because it's a constant. It's 1 over x dx, which then becomes 3 ln x plus c. So if I want to generalize the integral of x to the minus 1, it's going to be ln x plus c. So let's look at an example here. I'm going to evaluate this particular antiderivative, all over x squared dx. Well, the very first thing I'm going to want to do is I'm going to want to simplify this. So it's 3x squared e to the x over x squared plus 4x cubed over x squared minus 6x squared, and so on as I go. And then I'm going to cancel and simplify things. That cancels that. That whole thing goes. That cancels one of those. And this thing all goes. So when I simplify this, what I see is I get the integral of 3 e to the x plus 4x minus 6 plus 2 over x minus x to the negative 2 dx. And now if I'm going to antiderivative this, I do each part individually. I know the derivative of e to the x is just e to the x, so the integral of e to the x is also going to be e to the x. And the 3 just stays here. So if I take the derivative, I get this. Plus, well, I take my x, I add 1 to the exponent, it's 2. And then I think about what times 2 will come to take the derivative. The 2 would come down, times some mystery number would give me 4. So it's 2 times 2 to give me 4. I could have also thought, well, the 4x squared divided, multiplied by 1/2, because that's the 2 would cancel out. That's the 2. Minus 6x. Well, this is my natural logarithm, 2 ln x. I have to recognize that when it's a power of 1, it's also x to the minus 1 is what it means. And I know to take the derivative, I add 1 and I get x to the 0. That does not work very well. So it's going to be ln x. And then minus, I'm going to take my x, add 1 to negative 2, which gives me negative 1. When I differentiate, the negative 1 would come down, and I need to have a plus sign there so that I end up with a negative plus c.